Update you all. Now we are getting into the second part of the model 2. Before getting into the model 2, we will see the key terms, right? The key terms here are something like grid computing, web computing, cloud computing, and the XaaS stands for all as a service, like for example platform as a service, software as a service, and everything as a service, how we can get the service from others. First we will see what is a resource. A resource is an atomic information, right? Our atom is actually the smallest particle that is further indivisible. So in a similar way, the atomic information which cannot be further divided, right, that is actually called as a resource, right? That is usable during the computations. For example, the temperature of a single source, right, the temperature of a single sensor, or the status of a single street light, right, that is actually further indivisible and refers to one that can be read, written or executed. So this data, this resource can be read as well as written, and as well as it can be executed. And the resource includes the following things. The first thing is a path specification, right? So what type of resource it is, whether it is going to be a normal data or it is going to be a collection of data, something like that, right? So it specifies a path of specification. A method is actually that may be called as a function, right, or a program that operates that particular data, that resource, and multiple instances or just a single instance. So this resource may be a single instance or it may be a multiple instance. The data pointer, right? So a pointer which shows the current value of the data. A data object, a collection of all this data along with the specification, and a data store where the data can be stored. So all these informations will be available along with the resource. The system resource refers to the operating system, memory, network, server, software and applications, right? Normally a system resource, right, we call it as a both hardware resource as well as software resource. So the resource available in the system, what is the processor, what is the memory available, and what is the operating system available, what are the software and all those things available, and what are the supporting applications available. So the collection of all these things will form the system resource in order to execute one particular application. And what is the environment? Environment refers to an environment for programming, program execution, or both, right? So first time we need to program it, right? That is, we are going to create the program, and once that is created, we will be executing the program. So the environment in the sense, that's the hardware and software requirement for programming as well as programming execution, is called as the environment. For example, Cloud9 programming environment online for the BeagleBone. Say for example, if you are using a BeagleBone, then we have to use for the Cloud9 programming environment. And each and every application will be having its own programming environment. And Windows environment for programming and execution of applications. Of course, this we already know. Windows is actually the basic operating system along with the desktop PC or laptop PC, whatever it is. So it's a combination of hardware and software, and that will be useful for programming and execution of different applications. And for some cases, the Google App Engine environment is also there, right? Supposing a Google app will be creating a set of applications, right, which will be available in the internet, and that will be creating an environment for creation and execution of web applications either in Python or Java. So there are so many applications are there. Something like a Spider is actually there, or the Anaconda Navigator is there. So these are all some web applications. Jupyter Lab is actually a famous one. So these are all some of the web applications where we can create Python or Java programming as well as we can execute the program to see the results. What is a platform? It denotes the basic hardware, operating system and a network, right? So it's a combination of hardware and software again. Basic hardware, the operating system whichever we are going to use, and what is the network that is useful for connecting the system, right? So these are all the things collectively called as a platform. The software applications or services over the programs can be run or developed. So on one of the platform we can create our own programs that can be developed as well as that can be run, right? So this is actually the platform, and may provide browser and APIs, right? So this platform may provide browser access. So through browsers we can access the internet, and some APIs again some of the library functions, right? So it is used as a base for other applications that can be run or developed. So on a platform, we can have a browser through which we can run the other applications. And edge computing, a computing at the logical extremes of a network, a type of computing that pushes the frontier of computing applications, data services away from a centralized nodes to the computing nodes or data generating nodes. Right, already we have seen what is an edge computing. Edge computing is, there is actually a server, and this server will be connected to so many nodes. Right, these nodes will be maybe something like it can be separated by geolocation. Right, or it can be separated by the logical operation. Right, so each and everything will be separated, and we will assume that whenever I am giving a data for execution, that data will not be executed in the centralized node, but it will be given to some other computing nodes, and the data is processed in that. Right, so that is actually the logical extremes of a network. Right, so that is splitting the single system into multiple systems and connected as the edge devices. A distributed computing, again almost a similar thing, like refers to computing and usages of resources which are distributed. Right, instead of a single point, I will be having multiple resources, and this multiple computing environment over the internet. So all these things are connected through the internet network, and it can be considered as one computing system, location independent. So in the sense, we will be assuming there is only one computing system is available, but logically, that is distributed computing is possible. That is, each and every part of your program will be executed at different geolocations. Right, so that is actually the case of distributed computing. The computing resource at a distributed nodes. Say for example, here actually we have a central server, and there are going to be some distributed nodes, and all these nodes along with the central server, which should be cooperating with each other. Right, so all these things should be interconnected along with them, and this is movable without affecting the computations. Right, so these nodes, right, we can call it as a peripheral node or something like that, and these nodes should be movable without affecting the computations. We can either add the node or we can remove the node, but the original computation, actual computation, should not get affected. And these computing resources logically related, which means communicating among themselves using message passing and transparency concepts. So whenever a set of data is being processed in a server along with its distributed nodes, and they should be logically related. Right, so there should not be a deadlock, and all those things should not be there, and there should be equal message passing. Right, there should be interconnection between some sharing messages should be there that denotes the progress of the execution, and it should be transparent. So whenever a node executes that particular data, the execution of data should be available at all other nodes. And this is an overall circuit like an edge computing. And in the edge computing, on the left hand side, of course, there is nothing is there. Of course, the similar thing, like there is a web server, a device or sensor network is there. There are some local files are there. There is a coordinating node which collects all the data, and it organizes and sends it to the internet firewall. In addition to that, we can also have a distributed database node. Right, so there is a distributed database where the temporary data can be stored before getting into the internet. And on the right hand side, you can see there is a collection of things. Right, so all this data are collected here, and there is going to be a data center where the data is getting collected in using a server, and there is going to be a distributed database nodes. Right, so these distributed database nodes will be available at various locations, and the data collected are stored at these points. Right, so there are going to be collection databases available on the right hand side. So this is actually the simple architecture of edge computing. You will be having multiple nodes will be available. And a service, generally a service is an application call as, any application, right, that can call a service for utilizing the capabilities. And each and every service has a description, what is it for, and has its discovery methods such as advertisement for direct use or through a service broker. So each and every system will be offering some services, and these services will have its own descriptions, and they will also have some discovery methods through which other users can approach the service. Right, so that can be either using an advertisement, or they can have a service broker, right, which fetches some tasks for that particular service, and it binds a service level agreement between the service provider and the application. So again, we have two parties. One is the service provider, and who is going to be the user or the application. So there should be a service level agreement should be available between these two things. And the web computing refers to the computing using resources at computing environment of the web servers or web services over the internet. So there should be some web servers and the web services should be there, and most probably it will be on the internet, and we are going to use these computing resources for doing a computation that is called web computing, right? Computing at the web servers or web interfaces. And grid computing refers to the computing using the pooled interconnected grid of computing. Again, similar to your distributed computing, here again there is a grid of computing. Normally we call it as a grid, right? Electricity grid we know. Supposing in one state we are generating the electricity, and the electricity will be passed on to the other states where the electricity is not available or minimum available through the grid. So grid is actually the collection of networks, we can say, or collection of computing nodes, we can say. So here there is a pooled interconnected grid of computational nodes are available, and the resources and the environment in place of web servers. So there should be some resources and the environments on which we are going to do the computations that will be there in place of the web servers. There is a thing called utility computing. The utility computing refers to the computing using focus on service levels with the optimum amount of resources allotted. Say for example, I have one particular application, right? Say for example, I am going to use a Internet of Things platform for controlling a set of street lights. So in that case, it is going to be only on-off operation, and some basic controls strategy should be used. For making computations in this regard, I don't need a big server or big data. So in that case, what we can do is, I am going to limit my amount of resources consumed, right? So this is actually called as a utility computing. So I have a computing, and that is dedicated particularly for street light operation, right? That is the utility, right? The street light operation. And it uses optimum amount of resources. It is not going to have maximum resources or minimum resources. What is the optimum level? Only the optimum amount of resources will be used for that. And supposing if needs some other help, right? Supposing the resources are not sufficient, then it will take the help of pooled resources and the environment.